All right. I'm delighted today to speak with Kris Bennatti, CEO of Hudson Labs. They have a great AI product called Co-Analyst. It's designed specifically for investment management industry. They've been featured on CNBC, Financial Times, Bloomberg, among other places, and they do great work. So I know Kris has put together a few slides for us. I'm personally looking forward to hearing her insights. So, without further ado, I hand it over to Kris to get us started. Welcome, Kris.
Well, thank you so much for having me. This is very fun, a pleasure to be here. Let me share my slides. I'm gonna give a short background on Hudson Labs, but wanted to center the presentation around a topic that we discussed the last time we saw each other in New York around what goes into making an AI product great. How do specialized AI products come together and work, especially when we're targeting a, a user base that has very specific needs? And what's different between the way, say, Hudson Labs or more specialized AI product works than a more traditional chatbot like ChatGPT? Hopefully, will be interesting to many more people as well. As
Great.
you mentioned, we've been featured on CNBC, Bloomberg, Wall Street Journal, etc. We currently serve many hedge funds, asset managers tend to be focused on the buy side, customers with over $1 trillion in assets under management. We're going to be talking mostly about the co-analyst today, which is an alternative to a chatbot, but we are very well known for forensic risk analysis. That's particularly what I'm known for. So AI driven forensic risk. Fewer people in the finance industry are aware of my co-founder. He is, however, quite well known in the AI research community for various reasons. He just published a textbook that is quite literally flying off the shelves. It's called Designing Large Language Model Applications. It's published by O'Reilly. It's really exceptional and absolutely worth reading, even if you're not super technical. He was the co-chair of the privacy committee for the Bloom project, which was the largest multilingual model of its time, bigger than GPT-3. He's been the 4-time chair of the Toronto Machine Learning Summit. If you're not already following him on socials, I highly recommend it. Following him and talking to him is the only reason that I sound reasonably smart when I'm talking about AI. And if you want that for yourself, would definitely recommend it. He is the brain behind all of our proprietary research and all the really unique elements of Hudson Labs that make our work exceptional. So the big question that comes up often, it used to come up even more about a year ago. People ask the question, how is your AI model different from ChatGPT? It's a difficult question to answer because it doesn't make sense fundamentally. ChatGPT is not an AI model. Hudson Labs is not an AI model. What makes Hudson Labs great is in part its AI models, but there's a lot more going on the back end. And I'll try to walk you through what has to happen in order to get the right information from the right SEC filing, transcript, etc., at the right time, in order to get you, the investor, the information you need at inference time in real time. So not using stale information. In order to do that, you need a much more complex system that goes beyond just one generalist model. But even so, ChatGPT itself is not a model. A lot of the benefits that you're getting are from interacting with one generalist model. But there is more to it. It is a product. You can use the underlying models for completely different tasks that have nothing to do with chat. So you can use GPT-3 for generating tags, for classification, for all sorts of other items. The chat functionality is just one way of using the generalist model.
Great.
I've walked through a few of the elements. It makes our backend sound incredibly complex, which it is. And people say, how is your model different from GPT-3? Which is, of course, a challenging question to ask when we're using a whole bunch of different foundational models. A lot of them have continual pre-training and fine-tuning on top of them. So it's an ecosystem that's coming together to perform a service for you. It's not a model-to-model comparison.
Mhm.
So I think this surprises a lot of people, particularly VCs, who use ChatGPT and think, oh, hey, this model can do virtually anything. Application layer software is no longer relevant. We're good to go. That's definitely not true. So let me dig into why a single AI model is insufficient for most tasks, but particularly for investing or finance tasks. So I'm going to talk through a number of different reasons that a single model can't get the job you're trying to get done. But the most obvious one are limits to the context window. Does context window mean anything to you, Ehsan?
No,
No.
I think I have an idea of it, but if you elaborate, it would be great.
So when you're copy pasting something into ChatGPT, you can't copy paste everything. You can't put a full prospectus. There's a limit to how much information you can plop into the language model to have it work with. So that window, that prompt size, is called a context window. You can think of it as how long is the model's attention span. The reason the context window is so important is the context window, you need to get all inference time information into the context window. Any information that's not already in model memory needs to be in that context window. If a prospectus came out yesterday, it's not in model memory. So you need to get the relevant information into that context window in order for the model to do anything with that information. So before I dig in to the context window, just taking a step back here, there are 4 pillars to AI-based systems, and this issue around the size of the context window highlights the need for retrieval. So instruction following is really what most chatbots are doing. They're seeing your instructions and then recreating content that it either has in the context window or in its memory in order to attempt to give you what it wants. In order for inference time decisions to work appropriately, you need the right information in that context window for the model to perform its job. So that's retrieval. We get more complicated when we start looking at agentic workflows and reasoning. So reasoning would be, actual reasoning steps, deliberative thought, verification, iterative solution search. So when we're thinking about reasoning, we're thinking about models that take a lot longer, like O1, R1, not something that we're looking at with ChatGPT, which would be only the instruction following step is included in ChatGPT. But if you're going to build a finance-specific solution, you cannot build a solution that does not have an information retrieval mechanism, because there's never a situation where you're going to get all of the information you need into that context window or prompt every time. Great example, you pull up a long document let's say you're not familiar with this company or this document at the outset. You look for segment results. The model retrieves the information from that's relevant to you on page 40 or goes and finds it. But let's say you just chunked that document into sections in order to make it fit. You're going to miss potentially the information that tells you that those dollar figures are in pesos. That's a like 10x multiple error you're going to be making without the right context being provided to the model. So getting the information about what's the denomination of this figure in the actual figure into the context window is actually a relatively complex AI challenge. And those challenges become greater when you don't just have to put one prospectus into your prompt. You need to be looking at the most relevant information over 20 prospectuses or 20 10Ks or an entire search universe of conference calls, earnings calls, etc.
Right.
Yeah.
So I want to understand, I want to see if I understood this correctly. It looks like what sets your solution apart from ChatGPT is the fact that you have different underlying models. Each one is designed to do certain things. Maybe some of them sift through the numbers, some of them through the textual data, some of them different type of textual data. And then you make that more consumable to investment analysts, and you do it in such a way that the full context of the questions are captured so that you're not missing any crucial data. Is that a fair assessment?
That's definitely part of what sets us apart. But what this slide is supposed to convey is not necessarily what sets us apart, but why ChatGPT is not a solution that works for finance. So any finance specific tool cannot rely on just a model or model memory. You need to have a retrieval mechanism. So if you've ever heard the term RAG, retrieval augmented generation, that is a core component of any finance specific or any tool that needs real-time information. But also the way that retrieval is implemented is complex. It's variable. There's a lot of different ways to implement this functionality. And how well you do it is going to impact how well your model performs. So the retrieval mechanism is absolutely crucial to your perception of model quality. So if you're using Hudson Labs, you don't necessarily know that there's a retrieval mechanism happening on the back end. You're just trusting us to get the right information and make sure that the model sees it. But that technical capability has nothing to do with a core generalist foundational model, but is very important to making sure you get the right information. And to illustrate that point, so the obvious question is, why is that complex, Kris? I can just take search results and plug an AI model on top. Like, that seems easy. So there's a couple reasons that doesn't work. One is the bullet point at the top. Like, let's say you say segment results. The search result that you're going to get using a traditional keyword search or search backend isn't going to have the information the model needs to determine that figure is in pesos. It's not necessarily going to have the right contextual information in a traditional search result. But also, let's consider a situation where you're asking not a search question, but a more high-level reasoning AI question, like which management teams have the most negative view of Doge. If you type in the most negative view of Doge to a search platform like AlphaSense, you're just going to get matches for the words negative view and the words Doge. likely. In order to create a great AI platform, you need the information to be stored in a way that works for AI. So that means it needs to be stored in a vector database. There's a lot of different ways you can store those vectors. But if you want that question to work well, the vectors, you need to be storing the information in vectors and retrieving them. So because a vector database, the sentences you're retrieving will have information about whether or not it's negative or positive, et cetera, embedded into that vector, potentially, unlike a traditional search backend. So just briefly here, so other reasons that you can't just take one model, plug it on top of Edgar or your a bunch of broker research, et cetera, and have it work super well, is that no one model is exceptional at everything. People, I'm just going to focus on that number 2 briefly. People don't believe me when I say that no one model is exceptional at everything, because I think people who work in investing believe me when I say that. People who don't have this perception of AI being really, really powerful and magical, and they've seen all of these headlines like, oh, wow, GPT-4 is smarter than all my lawyers. I can fire them all. That would be very exciting. But we know this isn't true, right? We know that GPT-4 is not better than our lawyers because our legal fees are still really, really high, and none of us have actually outsourced that. And the reason for that is that the quick models like GPT-4 or GPT-3 that you interact with on a day-to-day basis are actually really bad at most things. I said not really bad. Their reasoning or intelligence capabilities are overestimated because when we test them, we're usually testing them using information they've already memorized. So in this instance, GPT-4 was trained on the questions and answers to the bar. So when you're testing it on the bar, it's an open book exam. It's pulling information it already knows. But when you're testing it on a new prospectus, it has to actually use reasoning. And we have an out of sample reasoning question list, and GPT-4 only got 12 out of 100 questions correct. So what that means is if you want a model that's exceptional at something, it's got to be a little bit specialized. Or in some instances, it has to be very specialized. And the best example of that would be guidance identification. Guidance identification is really hard for state-of-the-art generalist models because one area of underperformance of AI is being able to distinguish between present and future tense, which is fascinating. The limitations of AI are very, very different than the limitations of a human brain. They look and feel very different. So you're going to be getting some limitations like that you need to overcome with a very specialized model. A big reason clients come to us is, of course, for our guidance identification models, which we switch to our guidance specific pipeline whenever you type the word guidance outlook expectation. Happy to show you what that looks like if we do a little demo here. But then I just do want to head off the obvious follow-up question, which is if GPT-4 is only answering 12 out of 100 questions correctly, why aren't we just using DeepSeek R1 or O1 for everything? Yeah. Which is an excellent question. And the answer is I had Suhas had deep research write a report the other day. It was a great report, but it took 30 minutes. So these models that do have much, much better reasoning capabilities tend to be inefficient, which is fine for specific tasks. But if you're just trying to find a breakdown of segment results, you don't want a model that's going to take even more than 30 seconds because you can just be using control find.
Right.
Yeah. Which again, you want to be using the right model for the right application.
Understood.
And have some flexibility.
Great.
Yeah. So the big takeaway from this discussion of reasoning, specialization, how many different elements there are on our backend. It's not just retrieval, it's specialized pipelines. We have citations. We do away for the need for prompt engineering because we do a really great job of guessing what the user wants, specificity, etc. Guardrails that are investor specific rather than around politeness. So there's a lot going on our back end, and there should be a lot going on for any specialized AI product that you're using. In the future, if you're asking an AI salesperson about their product, asking them to compare their model to ChatGPT, if they look confused, this is why. But the big takeaway of why all of these moving parts are important is because people are really satisfied when you give them what they want in the format they want it. Specialized AI is a lot more powerful than just attempting to take an OpenAI wrapper, plug it in on top of Edgar. And frankly, that's one of the reasons we've seen so much frustration in the investment community. I know you said this when we talked earlier, Ehsan, there's not been a lot of adoption because people are seeing things like this, where a lot of products right now, they're taking a big foundational model, they do a little bit of fine tuning, they plug it on top of some sort of search mechanism, and you get results like this, where it looks right, but in this instance, almost half of the numbers are incorrect. What will be even more frustrating is 80% of the time they'll get something right, and 20% of the time will be wrong. It doesn't have to be like this. This is Perplexity Finance asking for NVIDIA guidance. And this is, of course, Hudson Labs. Yeah, so I think, yeah, if you are interested in learning more, I think we're going to go into a demo here. And Ehsan, let me know if you have any questions on that bit of the presentation. But anyone watching, please feel free to reach out to us at hudson-labs.com and to me, Kris Bennatti.
Great. No, I don't have any question at this point. This was hugely informative for me personally. I'm sure our audience also enjoyed it. So I think it would be great to jump into a demo. Looking forward to it.
Perfect. So this is the Hudson Labs co-analyst. So I'm going to start by demonstrating the really specialized components of the platform. So,
and I like, by the way, I like the clean look and feel of the solution. So it's very neat, and another plus is that it's browser based.
Yes, yes. No custom workflow that you have to go to get set up, which is our users really appreciate. And I'll pass on the comments to our designer just over there. So I think this query is going to highlight a lot of the differences between using a product that's designed for investing workflows versus attempting to use a generalist model that's not built for this type of use case. So I'm going to ask about CapEx guidance at Meta for the last 8 quarters. You can see I'm specifying my search criteria on the left-hand side and hitting enter. To make this fun, we can do it side by side with a generalist platform. So we're taking this information
Great.
from completely unstructured text, pulling out, converting the figures, putting them here. If you check the sources, you will see that all of these are, in fact, guidance. Over the last 8 quarters, we've put this into a time series so you can see the revisions. We've focused on the numeric elements for putting it into a tabular format. That all happens in a few seconds. And yeah, wow, when you try to do the same thing with a generalist model, you get a lot of missing data, actuals confused with guidance, very, very common. Not necessarily going to use sources that you trust. And most people give up at this point and would never come back and keep using the platform because there's just a trust issue. So that the power of specialized components, you can see that this button gets highlighted whenever we're running the guidance model. Very specialized model. And one thing I should note, I don't know, did you see there was a viral tweet a while back where a generalist model, I think it was GPT-4, couldn't tell whether or not 0.9 was bigger or smaller than 0.01.
I have not seen that,
Yeah.
but it seemed very funny.
Yes. So as I said, the limitations of AI models are very different from the limitations of the human brain and not always easy to predict. But LLMs are a lot better at complex mathematical equations than they are at basic arithmetic. Basic arithmetic tends to be an area where they fail. So you can see that NVIDIA's revenue guidance was disclosed as 43 billion plus or minus 2%. And we have a pipeline integrated. As part of our pipeline integration, we perform the arithmetic for you and make sure that these numbers are correct and not what we call LLM math.
Right. So in the earlier conversation that we had, I remember you mentioned that part of the reason your solution delivers results with higher accuracy is because besides just running the query, the data extraction, and task of that nature, you do a lot of preparatory work in the sense that you tag the information so that when the system wants to extract the data, it pulls the right data. Maybe you can also talk a little bit about that and how you accomplish it.
Yeah. So you're not going to be able to view that
Mhm.
from the front end UI, but a lot of that tagging has to do with the problem I indicated earlier, where sometimes the information you need about a specific topic is on pages 1 and pages 40 of a document.
Mhm.
So a lot of our pre-processing is about facilitating the matching of those topics for any specific document. So we do a lot of topic tagging, and we also do something that we're quite well known for, particularly for risk analysis, which is boilerplate or noise suppression. One problem that you may have found in using AI is not that it's wrong, it's just giving you a ton of nonsense that isn't relevant. And that's the problem that you saw in that perplexity screenshot that I showed you when I asked for guidance for a specific. It was all correct. It just wasn't the specifics that I was looking for. In finance in general, we have a massive noise problem. I think someone once estimated that 70% of a 10K is boilerplate. So, and the more noise you have and the more overlap there is between the words in the noisy bit and the information that actually has meaning could impact the stock price, the more likely a model is to get confused. A great example of that would be many issuers have in their 10K, they say something like, we could be subject to an SEC investigation in the future. And then there's a far fewer issuers that say we are subject to an SEC investigation. The difference between those two sentences is not huge, but one we can completely ignore and just scrub it from what the model is going to be looking at. And the other one's going to be hugely important. So getting the right information to the top, we call that mechanism relevance ranking, is also a really big, important, a big part of our pre-processing and storage process.
Understood.
So I'm going to ask the model to compare all tariff commentary for the recent calls for these health companies. And hopefully what you'll see is what I've just talked about. The model concentrating on high impact numeric information first, company specific information, and ignoring the noise. If anyone's watching this, try doing this using a generalist model. You're going to get widely different results. Yeah. And I think this isn't something that we've necessarily chatted about
Right.
uh, today, but one of the things that I've been talking about on other calls is how structure and format no longer matters with AI. You know, we've spent so much time being like, oh, what call did they say X in? Is it in the press release or the earnings call? Is it in the presentation? I'm not going to even bother looking up their backlog data because they only talk about it in XYZ places. But I really wish I had a trend analysis. That type of, so for instance, I believe Costco only talks about traffic on their earnings calls. I could be wrong about that, but you'll get, it's a good example anyway.
Right.
So I'm just asking for traffic at Costco for the last 8 quarters. The model is going to go through, guess how I want that information. And you can see here, it's gone through all this completely unstructured data, structured it for me, pulling out US versus worldwide. It's including commentary. I can come back here and say, hey, that's not what I wanted. I want it in a different format. But even though this is completely unstructured data, there's all of these different documents we need to look through. I've just consolidated every single one of those metrics. I can copy this into an Excel spreadsheet start doing my own analysis. And that took what, under 8 seconds?
Yeah. No, this was
Yeah.
very, very informative. As I mentioned, very intuitive solution, web-based. Looking forward to hearing about the new features that you're rolling out. But I think as it is, Hudson Lab Co-Analyst can add a lot of value to many investment management firms in terms of doing research, but also other day-to-day activities and workflows. Wonderful. Well, thanks again for your time, Kris. As always, it was a pleasure for me, and I learned a lot. And I'm looking forward to connecting again in a few months to see what's new with Hudson Labs. Thanks again.
Perfect. Thank you.
Bye.